take a quick look at construction problems throughout the world, right? In North America, construction is a labor shortage industry, right? It's very hard to get new people into construction, and even someone to push a broom around and always clean up a site is something around $38 an hour. Um, in South America, the problem in, say, a country like Brazil is that construction supervisors and engineers, civil engineers, are hard to get around, right? And so a lot of times sites may slow down their progress for lack of engineering talent. Europe has an aging workforce, and so it's getting, the knees are getting out and the backs are giving out and stuff like that. And Asia is getting really big into lean construction and agile construction techniques, which really require a lot more to be done on site. So the principles that we're using here is that if you're going to make it possible for workers to work from home, you're going to need something like a robot, right, to actually do the physical labor that the human's going to drive. You're going to need procedures to work with those robots safely and effectively, right? How do you mark off where the systems are going to be? How do you charge things? When do you replace batteries? All those other kinds of simple things. You're going to need people both to work with the machines and to work around the machines. And of course, you're going to need technology to enable this entire work from home kind of thing. Now, a question that came up a lot while we were talking to people is why use humans at all? Why don't you just have a full AI system? So first of all, this is not a computers taking our jobs kind of thing, right? There's actually going to be a few new people that'll have to be involved in this kind of thing. Uh, I don't know what this will be. Was it some sort of new trade? I just call it a robot wrangler. But this is the person who is responsible on the site for getting the bots in place, keeping them charged, running around and pushing emergency stop buttons if necessary, whatever else is needed to enable the human operators to actually work from home, right? And then, of course, you have the human operators at home physically operating the robots. Full automation is unsafe. Everyone knows about the Uber crash where the robot just chose to drive over the bicyclist. Tesla's had quite a few incidents as well. Even with their remote parking feature where you just summon the car from the parking lot into your own garage or wherever kind of deal, with you watching it line of sight, there have been accidents. Um, Full AI robots are stupidly expensive. The Spot Mini, for example, is 75,000 for the robot, and another 3,500 a month for something like Spot Walk, which is their walking around taking photographs software package. And Google says that it's going to be a long time coming. It's far away in time. That they think it might be 15 to 20 years before they have full self-driving level 5 working themselves, right? And so it's not something that I think is tomorrow's problem, right? What the problems really do seem to be, though, is that we don't get to keep our workforce long enough, right? People, their backs give out, their knees go out, give out. People have trips and falls on site. People get sick. COVID's a great example, but it's a common cold or the common flu, right? And so if people could work at home, well, those are people who don't get injured, and if they're able to work with with a computer or with a cell phone or something at home, and still be effective on the job site, then they can stay in their career a lot longer. Plus, I suspect that a system like this will enable the industry to attract younger workers because it's less messy, it's less backbreaking, it's more like an office environment. You can even have like that whole office camaraderie kind of thing going. So here's how we built it, the tools that we used, I should say. So the robot itself is just a Raspberry Pi, an Arduino, a Logitech webcam, and some stepper motors, right? Literally stuff you can go down to your local Fry's or Vetco Electronics or whatever and just pick up and hack together. Communications is over a cloud dispatch queue, which we open source. That's the URL is right there, GitHub IPRY dig dispatch. And then for the phone part of it, we just use the Go.game engine to very quickly throw together. Here's the screen and controls, and these are all just standard controls in Go.dot that we just put together. All right, so what does it take to really do it? Like not just do it at a hackathon, but if we're going to do it for real, well, then you're going to have to solve the Wi-Fi at the last mile kind of problem. That's kind of a solved problem. Commercial Wi-Fi routers exist, and you just have to learn how to deploy them kind of deal, which a lot of firms don't do because of the cost or because of the convenience of it. But if you actually have a use case, it sounds like they would. Um, Another thing you'd have to do, like this current design is just a single communication core in the cloud, but it really makes sense to make the communication cores both serverless and multi-cored. One would handle control messages from the joysticks from the user, as well as that same core would handle sensor feed, so that's the real-time core. You would also want to have a separate core for the video feed, and then you would have a separate core just for the user themselves. And that core enables us to handle the fact that let's say the user is in Brazil or something like that. Well, there might be a lot of latency between like if you picked a core in, say, France, that wouldn't make a lot of sense just for the latency that you'd introduce. So you'd have to uh, create a core near where the user is located, as well as a core near where the robot is located, right? Of course, you need operators. And now that you've got this cloud-enabled system, you can actually charge a monthly fee for those per robot for the cloud services. So it creates a natural billing point. And lastly, you need the on-site robots. And I'm guessing they have to be really affordable because if the robots are $75,000, then no one's going to hire them, right? No one's going to bother to do it this way. So we'll just do that, right? Cheaper robots, on-site, they can run simple macros, but they're really designed for human interaction and human operation. What about safety? Yeah, so one of the things that came up a lot of time in conversations was how do you make this safe? Well, this is kind of a layers of safety approach. The first thing is the robot is small. If it drives into you, it literally just feels like a cat stepping on you, so it does not physically hurt you. Second of all, the robot has its own onboard AI, and that onboard AI is actually broken up into two separate things. One of them is really simple distance sensors. Hey, I've got an ultrasonic. If I see something that's within this range, I just stop and wait. Watchdog timers, if I lose connectivity to my main Arduino or, sorry, to my main Raspberry Pi or to the internet, then I just shut down. Of course, there's the big red button shut off switch, which this robot didn't have. It did actually have a toggle switch instead. And then the real robot, I think, would be really highly visible. There'd probably be a flashing yellow light on top like a tow truck, and the whole thing would probably be painted bright yellow. And then when it's backing up, there would probably be, a buzzer or a beeper or something like that so that you know. And of course, you'd have to train operators on how to use the thing because even when we used it, we kept forgetting what does this joystick do again? So it's definitely a learning experience to use it, and so we'd probably have to turn that into like a full game or something like that. But that way, you'd have a training set up so that people know how to actually work it safely, and then the inherent safety of the size as well as the AI and other electronic safeties that are built in and design safeties. Now, this robot may not be the right approach for low-cost labor markets like Brazil. They seem to have a different problem. It's not the ordinary labor that's hard for them. It's the engineers, the construction engineers and the managers. And so really the robot's role would become more around communication, as-built project and documentation kind of stuff. It also makes a lot of sense where people are trying to use lean construction and do a whole bunch of just-in-time kind of things where you order everything at the end. And then we think that there might be some plays especially in these low-cost labor markets, to adapt with other in-field technologies like 3D printers. Like what happens if you attach a printhead to this robot and you can, lay down a special concrete form on site and things like that. So there's really some additional explorations that could be done. So that's pretty much the entire idea, right? It's remote labor, and you can actually physically build from home. So thank you very much.
Were y'all able to hear that okay?